Welcome to this lecture on Examples of Derivatives of Inverse Functions by Dr. Rajesh Singh.
Good afternoon, everyone.
Good afternoon, sir.
So in the last class, we did with the inverse functions, right? We did differentiability of inverse functions. So what was the result when inverse function is differentiable?
जो continuous or strictly monotone.
Yes, the function should be continuous and strictly monotone. Then we can surely say that our inverse function will be differentiable. Or inverse function जो है by continuous inverse theorem, it will be strictly monotone and continuous also. Okay.
Yes, sir.
Okay. So now we are going to do some examples. Last time also we did 1 or 2 examples. Today also we will do some examples on inverse function, and then we will do some exercise questions today. Okay. So let me just share the whiteboard with you all. So we are going to continue with inverse function. So we will do some examples based on that. Okay. So let us do the first example. So now we are given the function f(x) equal to x to the power n, and we have to find the inverse of or derivative of inverse of f. Okay. So let f(x) equal to x to the power n for all x belonging to I, where I is the interval 0 to infinity. Okay. So we're taking I to be interval 0 to infinity. Fx is the function x to the power n for every x in I, and n belongs to some natural number n. Okay. Show that the if g is the inverse of, पहले ये लिख लेते हैं, if g is the inverse of f on f of I, j equal to f of I, then show that g dash y is equal to one by n y 1 by n minus 1 for all y greater than 0. Okay, so this is what we have to show. Is it fine? So how you will prove it? So we have to find the derivative of inverse of f. Okay. So we don't need to find the inverse. We will just use our inverse function theorem, derivative of inverse function theorem to get this derivative. Okay. So first, what we will have to show, we will have to satisfy the hypothesis of inverse derivative of inverse function theorem. So what we have to show first?
It's continuous.
Yes, we have to show that f is strictly monotone and f is continuous. Okay. Right.
Yes, sir.
Okay. So we know that f dash x is equal to n x to the power n minus 1 for all x belonging to I, right? This function is differentiable, right? And its derivative is given by this n x to the power n minus 1. So f dash x is greater than 0 for all x belonging to 0 to infinity, right? So what does this imply? This implies f is
Strictly increasing.
strictly increasing. In fact, monotone bead, it is strictly increasing on I. Also, ठीक है, ये इसको ये तो नेक्स्ट लाइन में कर लेते हैं, पहले हम इसे कंटिन्यूअस बोल देते हैं. Why it will be continuous? since f is a polynomial function, right? It is a polynomial. F is continuous and differentiable everywhere on its domain. Okay, so that's why it is continuous and differentiable on I. So or strictly increasing भी show कर दिया हमने. So what does this imply? So hence f is strictly increasing and continuous on I. So by continuous inverse theorem, G is strictly increasing and continuous on I, right? Is it fine?
Yes, sir.
So G is strictly increasing and continuous on I. Now what next? Also f dash x कहाँ पे जीरो है? कहाँ पे जीरो नहीं जीरो है? Also for all x not equal to 0, f dash x is not equal to 0, right? This is non-zero for every x. So by derivative of inverse function theorem, what will happen? G is differentiable on 0 to infinity. ठीक है, 0 को exclude करना पड़ेगा क्योंकि 0 पे it is 0, it might be 0. So differentiable on 0 to infinity and g dash y is equal to 1 by f dash of gy, right? For all y belonging to 0 to infinity. Is it fine?
Yes, sir.
Okay. So g dash y is equal to 1 by f dash of gy. Now, अब कोई भी अगर point है y, if we have some y in f of I, तो what will be its preimage? y किससे आएगा?
X.
gy basically अपना क्या होगा? gy will be y to the power 1 by n, right? Yes.
Yes, sir.
gy will be y to the power 1 by n because our fx is x to the power n और x अगर f हमें g निकाल वो g of y क्या हो जाएगा? It will be y to the power 1 by n. Okay, so just apply that. So now since f of x is equal to x to the power n for all x belonging to I, so for any y belonging to f of I, y is equal to f of y to the power 1 by n, right? So this is the preimage, right? So hence g dash of y is equal to 1 by f dash of gy. So this implies gy is equal to y to the power 1 by n. So this is f dash of y to the power 1 by n, and what is derivative of any point? It is n y to the power 1 by n minus 1, right? So this, yeah, this will be in the denominator. This thing will be in the denominator. 1 by y this. So this is 1 by n, or इसको you can simplify it, so it will become y, क्योंकि जब न्यूमरेटर में ले आओगे तो it will become negative, so it will become 1 by n minus 1, right? Is it fine?
Yes, sir.
Okay, fine. So हमने अब दो चीजें कर ली हैं. If you look at this, then what we have done is basically पहले हमने एक prove करा था result for natural numbers. Now what we have done, we have also done for so basically we have found the derivative of x to the power 1 by n also, and it is nothing but 1 by n y 1 by n minus 1, right? Okay, so अभी तक देखो हमने दो result कर लिए हैं. So what we have done is, so now we have shown that. So now we have shown that first, if fx is equal to x to the power n for all n belonging to n, so we have shown two results. For any natural number n belonging to n, we have shown what we have shown. If fx equal to x to the power n for all x belonging to 0 to infinity, then f dash x is equal to n x to the power n minus 1, ये वाला formula. And second thing what we have shown also, we have shown this. If fx is equal to x to the power 1 by n, okay, for all x belonging to 0 to infinity, ये ध्यान रखना कि this function is not differentiable at 0, then f dash x is equal to क्या हो जाएगा 1 by n x 1
X
by
to the power.
minus 1 for all x belonging to 0 to infinity. So these two results we have shown. Now we will prove it for natural or rational number, positive rational number m by n. ठीक है. So अब इन दोनों रिजल्ट को क्लब करके we will prove it for positive rational number. ठीक है. Yes, we have shown these two results. ये पहले हमने करा था for natural number. Now we have shown it for if we take the number of the form 1 by n where n is a natural number. Now what we will do, we will show it for any positive natural number. Okay, is it fine?
Yes, sir.
So let us take, so question, let r equal to m by n where mn belongs to z positive be any positive natural number. Okay, okay, so we have picked any positive natural number, right? For each, yeah, define r from I to r as r of x is equal to x to the power r. ठीक है. For all x belonging to I, which is the interval 0 to infinity. So we are taking I to be the interval 0 to infinity. अभी इसी पे काम कर रहे हैं हम. ठीक है. Is it fine?
Yes, sir.
Okay. Now how you will find the derivative of r? So r is, so that is rx is equal to x to the power m by n. अभी तक हमने जो रिजल्ट्स करे हैं उसके हिसाब से कैसे लाओगे इसका डेरिवेटिव? फाइंड r dash x.
सर इसे दो पार्ट में ब्रेक कर देंगे.
तो बताओ कैसे करोगे?
सर एक x to the power m और x to the power 1 upon n.
ओके, नहीं, लेकिन वो तो अलग चीज हो गई। प्रोडक्ट ये कहना चाह रहे हो कि यू कैन राइट आर एक्स इक्वल टू दिस। लेट अस solution. So you want to say rx is equal to x to the power m dot x to the power 1 by n। ये तो नहीं होगा।
नहीं सर, ये तो नहीं है, ये तो प्लस हो जाएगा।
हाँ, so you can write it like this, x to the power 1 by n times m।
यस।
ठीक है, so हमें क्या करना होगा, we will have to put it as a composition of two functions। ठीक है, so let fx equal to x to the power n, oh sorry m, for all x belonging to 0 to infinity, and gx is equal to x to the power n for all x belonging to 1 by n for all x belonging to 0 to infinity। okay, ठीक है, is it fine?
यस सर।
So since g is differentiable on 0 to infinity and f is differentiable on, इसको एक लाइन बीच में ऐड कर देते हैं, पहले शो कर देते हैं कि r is a composition of two functions। now rx is equal to x to the power m by n, which is equal to x to the power 1 by n times m, which can be written as f of g of x for all x belonging to 0 to infinity। yes, so r is the composition of these two functions। now since f is differentiable on 0 to infinity, or g is differentiable and f is differentiable on this, so by algebra of differentiability, r, which is equal to f of g, is differentiable on 0 to infinity। also, what is the, by chain rule, what is the derivative of r?
f dash g of x into g dash x।
f dash g of x into g dash x for all x belonging to 0 to infinity। so this is f dash g of x is
f dash of
yes
x power
1 by n into g dash x is
1 by n into x to the power 1 by n minus 1।
yes। okay, now so for f dash x का फॉर्मूला क्या होता है, n times x n minus 1। so यहाँ पे x to the power n है, so this will be n times x 1 by n n minus 1, right? dot 1 by n x 1 by n minus 1। sorry, this will be, ये इसका तो पावर m है ना, so ये will get m here, right? yes, क्योंकि f dash x is x to the power m, so you will get this here। fine,
यस सर।
so now just add them all। so ये हो जाएगा क्योंकि m by n आ जाएगा, so this is equal to m by n and all the powers of x will be added, so you will get m minus 1 by n plus n minus 1 by n, right? sorry, this is 1 minus n by n and this is m minus 1 by n, उल्टा हो गया। ठीक है, so when you will add them, what you will get, so this is nothing but m by n x, so m minus n by n, which will be m by n minus 1। ठीक है, so which is equal to r x r minus 1, hence r dash of x is equal to r times r minus 1 for all x belonging to 0 to infinity। ठीक है।
यस सर।
सो वी हैव शोन, अब ये भी शो कर दिया। अच्छा एक चीज और, अगर r जो है ये ग्रेटर देन 1 होता है तो देन यू कैन शो दैट दिस विल बी डिफरेंशिएबल एट 0 आल्सो। ठीक है, लेकिन वो एप्सिलॉन डेल्टा डेफिनेशन से आएगा, उसको प्रूव करना। क्वेश्चन, if r is greater than 1 and r belongs to q, then show that rx equal to x to the power r for all x belonging to 0 to infinity is differentiable at x equal to 0, and further show that r dash 0 is equal to 0. So ये epsilon delta definition से आएगा, ठीक है, उससे you can easily prove, या लिमिट वाली डेफिनेशन भी अप्लाई कर सकते हो। क्योंकि इनफैक्ट ये लेट अस डू इट आल्सो, लिमिट वाली कर लेते हैं सॉल्यूशन। तो कैसे स्टार्ट करोगे? कंसीडर लिमिट x टेंड्स टू 0 पॉजिटिव, क्योंकि लेफ्ट साइड से तो आ ही नहीं रहे, हम राइट साइड से आ रहे हैं, या लेट अस टेक 0, क्योंकि अगर r पे डिफाइन कर दो इसे, ठीक है, कोई फर्क नहीं पड़ता, वी कैन डिफाइन इट ऑन r आल्सो, बट नेगेटिव, अगर ये रैशनल r जो है, क्योंकि r ग्रेटर देन 1 लिया हुआ है, नेगेटिव पे प्रॉब्लम कर सकता है अगर इवन नंबर है डिनोमिनेटर में। सो लेट इट बी, अभी पॉजिटिव ही रख लो, ठीक है। सो दिस इज rx minus r0 upon x minus 0. So what will be this? Limit x tends to 0 positive,
x to the power r.
so this is xr minus x, ये तो 0 ही जाएगा, this will be 0 upon x, right? So this is limit x tends to 0 positive, x r minus 1 by x. अब क्योंकि power is positive, right? This power is positive because r is greater than 1. So this will go to 0 since r minus 1 is greater than 0. ठीक है? Is it fine?
Yes sir.
So hence r dash 0 is equal to 0. In fact ये अभी हटा ही दो इसको हम, ठीक है। So this is ये r dash 0, fine. So इस तरह से you can easily show that it will come out to be equal to, और ये तो इसको बेटर रहता कि we could have gone with उससे भी कर सकते थे एप्सिलॉन डेल्टा डेफिनेशन से, क्योंकि xr minus 1 आ गया, so x के टर्म्स में ला सकते थे इसे। Anyways we are through with this, yes. So this function is different, ये this is rx equal to x to the power r is differentiable for every x in 0 to infinity. At 0 it is differentiable when you take r to be greater than 1, okay. If you take r to be greater than 1, then it comes out to be differentiable at r, fine. So अब हमने तीन चीज शो कर दी, अब हमने नेचुरल के लिए शो कर दिया, we have shown it for numbers of the form 1 by n where n is a natural number. Now we have shown it for positive rational numbers, ठीक है। So ये तीन चीजें हमने शो कर दी हैं, बाकी सिमिलर वे में you can then using limit and all those things you can show it for negative numbers, negative natural numbers, or negative, sorry, rational numbers and real numbers also, right? क्योंकि हम ये तो जानते हैं कि ये रिजल्ट हर एक रैशनल, हर एक उसके लिए ट्रू होता है किसी भी रियल नंबर के लिए। अगर इफ यू हैव x to the power a, then a, the differentiation of x to the power a is a times xa minus 1, right?
Yes sir.
So
Sir?
now, yes,
सर उसे एप्सिलॉन डेल्टा डेफिनेशन से कैसे प्रूव करेंगे?
ये
x to
आगे
the power,
ये सेम ही देखो, उसमें क्या करोगे, उसमें लेकिन लिमिट लेके चलना पड़ेगा 0, ठीक है। तो 0 लेके चलोगे तो ये rx minus r0 upon x minus 0 minus 0, So this will come out to be this form x to the power r upon x. So ये आ जाएगा फिर उससे, right? इसको फिर आप कर
Yes.
सकते हो क्योंकि तुम्हें x के टर्म्स में तो लाना है, तो वो रूट ये अपॉन डिनोमिनेटर इसमें 1 बाई एप्सिलॉन एप्सिलॉन टाइम्स 1 बाई r माइनस 1 करके यू कैन इजीली ब्रिंग, ठीक है, क्योंकि पॉजिटिव है ये, सो उससे ला सकते हो, ठीक है। क्योंकि इसी में आ जाएगा ना, इसी पे आ जाएगा। सो नाउ यू वांट दिस टू बी लेस देन एप्सिलॉन, दिस थिंग टू बी लेस देन एप्सिलॉन, तो डेल्टा क्या लोगे, वो x पे डिपेंडेंट करेगा, तो उससे यू कैन इजीली टेक।
सर डेल्टा यहाँ पे क्या लेंगे सर, वो समझ नहीं आ रहा है।
x to the power r minus 1 you want to show this less than epsilon,
यस सर।
so that means you will show that x is less than, so this is your delta,
यस गॉट इट।
ठीक है। Okay, now let us find the derivative of sine inverse x, ठीक है। So we will find the derivative of sine inverse x. The question, let fx equal to sin x for all x belonging to minus pi by 2 to pi by 2, इसका जो प्रिंसिपल डोमेन है, ठीक है। Show that the inverse of f, the inverse gx equal to sine inverse x of f, ठीक है, is differentiable on minus 1 to 1, and what will be its derivative,
1 upon under root 1 minus x square.
and g dash x is equal to 1 upon root 1 minus x square for all x belonging to minus 1 to 1. Fine. So this is what we have to show. So let us start. So again we have to apply inverse function theorem. So उसके लिए क्या करेंगे? Yes.
sin x को continuous and monotone, strictly
Yes.
monotone.
Since sin x fx equal fx f is trigonometric function. Trigonometric function. So it is continuous and differentiable on its domain, right? Also f dash x is equal to क्या हो जाएगा, cos x for all x belonging to minus pi by 2 to pi by 2. So what about sin of f dash x? So clearly f dash x is greater than 0 for all x belonging to minus pi by 2 to pi by 2. Pi by 2 पे they become 0, right? So pi by 2 नहीं लेंगे, बाकी तो क्योंकि देखो this is cos of minus x is cos x. So basically यहाँ पे जो है x 0 से pi by 2 पे है और वहां पे पॉजिटिव होता है, so this is positive everywhere except at the points minus pi by 2 and pi by 2, ठीक है। So hence f is strictly increasing on क्या हो जाएगा,
Open interval minus pi by 2 to pi by 2.
yes, on minus pi by 2 to pi by 2 और एंड स्ट्रिक्टली इंक्रीजिंग एंड कंटिन्यूस कह देते हैं सीधे साथ यहीं पे, या चलो एक लाइन लिख देते हैं, ऑन माइनस पाई बाई 2 टू पाई बाई 2. सो बाय कंटिन्यूस इनवर्स थ्योरम gx equal to sine inverse x is strictly increasing and continuous on, क्या हो जाएगा कहाँ पे,
minus pi by 2 to pi by minus
नहीं f of this, f of minus pi by 2 to pi by 2, ठीक है, and what will be the set which is equal to minus 1 to 1 because it takes the values minus 1 to 1, ठीक है, is it fine?
yes.
अच्छा, स्ट्रिक्टली इंक्रीजिंग मत बोलो क्योंकि थ्योरम जो है कंटिन्यूअस इनवर्स थ्योरम इट सेज स्ट्रिक्टली मोनोटोन, ठीक है, सो मोनोटोन, so this gx equal to sin inverse x is strictly monotone and continuous on this f of minus pi by 2 to pi by 2 which is nothing but the interval minus 1 to 1, ठीक है, ये सारी वैल्यूज देता है माइनस 1 to 1 और माइनस 1 साइन माइनस पाई बाई 2 पे आता है और 1 साइन पाई बाई 2 पे आता है, बट दे आर नॉट इंक्लूडेड, इसलिए यहाँ पे भी इट इज नॉट इंक्लूडेड, फाइन। Yes, since f dash x is not equal to 0 for all x belonging to minus pi by 2 to pi by 2, so by derivative of inverse function theorem, क्या हो जाएगा, gx equal to sin inverse x for all x belonging, yeah, is differentiable on minus 1 to 1 and by chain rule, sorry chain rule name, and g dash of y is equal to 1 by f dash of gy, ठीक है, is it fine?
Yes, sir.
Now for any y belonging to minus 1 to 1, क्या हो जाएगा, y will be equal to
Sin inverse x.
sin x for some x belonging to minus pi by 2 to pi by 2, right? So gy is equal to, ये fx कर दो क्योंकि ये तो रेंज सेट है ना f का, दिस इज f ऑफ i, या इसको इस तरह से क्योंकि हमें gy को f के टर्म्स में लाना पड़ेगा ना, सो दिस इज योर f ऑफ minus pi by 2 to pi by 2, so this implies that y is equal to f of x for some x belonging to minus pi by 2 to pi by 2, so g of y is equal to g of fx which is equal to x, so यहाँ पे x आ जाएगा हमारा, ठीक है, so hence g dash y is equal to 1 by f dash of gy, so which is equal to 1 by f dash x, so what is 1 by f dash x, it is 1 by cos x, अब इसे वापस y के टर्म्स में लाना पड़ेगा, so इसे वापस पहले हमें साइन के टर्म्स में लाना पड़ेगा, ठीक है, साइन स्क्वायर x, राइट, and which is equal to 1 minus y square, since phi is equal to fx is equal to, fine, is it fine? So this is how you get this formula, ठीक है, so for all y belonging to minus 1 to 1, ठीक है, so पूरा प्रोसेस इसी तरह से करना है, ये नहीं कि डायरेक्टली तुम फॉर्मूला लिख रहे हो साइन इनवर्स का डिफरेंशिएशन का, you have to bring this gy into form of this f, क्योंकि तभी अप्लाई कर पाओगे f डैश, क्योंकि g तुम्हें, ठीक है, इज इट फाइन?
सर यहाँ से एक्सप्लेन कर दीजिए एक बार और।
कौन सा? देखो
सर
अगर हमने ये अभी हमने अगर ये करा होता जी डैश, या तो इस तरह से भी कर सकते थे, जी डैश इज 1 by f dash of g y, so this is nothing but 1 by f dash of sine inverse y, right? So this is cos sine inverse y, so this will be 1 by 1 minus sine of sine y whole square, so this is 1 by 1 minus y square। इस तरह से भी कर सकते थे, बट ये जो है कई बार हमें जी एज अ जी जो है साइन इनवर्स, यहाँ पे साइन इनवर्स y लिख दिया हमने क्वेश्चन में, बट अगर ना नहीं दिया हो हमें साइन इनवर्स x, सीधे बोला हो कि फाइंड द डेरिवेटिव ऑफ दिस, तो देन यू कैन नॉट अप्लाई दिस, राइट? यू कैन नॉट राइट साइन इनवर्स x। सो उस केस में क्या करना होगा तुम्हें, यहाँ पे ये क्योंकि y जो है दिस इज -1 to 1 एंड दिस सेट इज नथिंग बट अवर इमेज ऑफ दिस इज f of i, राइट? जो हमारा डोमेन ऑफ g होता है दैट इज f of i, so that means our y is some y is x is a pre-image of y here, right? so हमारे पास कोई pre-image होगा y का, ठीक है? so हमने कुछ नहीं करा है, y is equal to fx, we can write it like this, या इस तरह से भी कर सकते थे कि sin inverse y को ही लेके चल देते, so दोनों तरीके से कर सकते हो, ठीक है? is it clear?
यस सर।
यार चलो रहने दो, इसे अल्टरनेट कर देते हैं so that you can ठीक है, so that कभी अगर ये वाला यूज करना तो you can use it this also। okay fine, so the derivative of sine inverse does not exist at the endpoints -1 and 1, this you can show yourself, ठीक है? ये ट्राई कर सकते हो, क्योंकि थ्योरम से तो हमारे पास आएगा कि क्योंकि वहां पे जो डिफरेंस ये हमारा ये fx है दैट इज 0 एट -π/2 एंड π/2, सो उसकी वजह से हम उस जहां पे 0 होता है वहां पे हमारी थ्योरम वर्क नहीं करती है, सो वी कैन टॉक एट द पॉइंट्स वेयर द फंक्शन इज नॉन जीरो, ठीक है? ओके, सो लेट अस डू सम क्वेश्चंस, एक क्वेश्चन कर लेते हैं, ज्यादा टाइम तो है नहीं हमारे पास, सो let us take this function। So f is a function defined by fx equal to x square for x rational x, and it is 0 for irrational. We have to show that the function is differentiable at x equal to 0 and f dash 0 is, so this we have to find। what should be f dash 0? क्या लगता है क्या होना चाहिए?
सर 0।
0, yes। ठीक है, अगर डेरिवेटिव एग्जिस्ट करेगा तो पक्का वो 0 ही होना चाहिए और कुछ नहीं हो सकता, क्योंकि इसको डिफरेंशिएट करोगे तो 2x आएगा और इसको डिफरेंशिएट करोगे तो 0 आएगा, एट 0 दे मस्ट बी इक्वल, सो 0 आएगा, ठीक है? सो 0 होना चाहिए, सो हमें शो करना है कि f डैश, सो हम 0 से स्टार्ट करेंगे, सो कंसीडर fx minus f0 upon x minus 0, so now we will show that this 0 is the limit of this। so अभी हमने माना करा नहीं है, लेकिन we know intuitively we know, क्योंकि हमें लिमिट पता होनी चाहिए, अगर एक्सटर्नल डेफिनेशन लगा रहे हैं तो हमें ये पता होना चाहिए नंबर, ठीक है? ये हमें लेके चलना पड़ेगा कोई नंबर, वी कैन नॉट वर्क विदाउट इट, ठीक है? सो 0 से हम हमारा इंट्यूशन कह रहा है कि इट शुड, अगर एग्जिस्ट करेगा तो इट शुड बी 0, सो वी आर स्टार्टिंग विद 0, so this is your fx minus 0 upon x minus 0 minus 0, so this is nothing but fx upon x, so this is your mod fx upon mod x, right? yes,
यस सर।
now what is this? this is less than equal to x square, right? क्योंकि fx की दो वैल्यूज हैं, या तो 0 है या x स्क्वायर है। अब ये x अगर रैशनल है तो ये 0 हो जाएगा, सॉरी ये x स्क्वायर हो जाएगा, अगर इरेशनल है तो 0, दोनों में बड़ा कौन सा है? एक्स स्क्वायर, तो एक्स स्क्वायर लिख सकते हैं हम, राइट? यस,
यस सर।
ठीक है। ये जो ट्रिक हमने पहले भी कई जगह यूज कर रखी है, जहाँ पे रैशनल रैशनल होता है तो हम ये ट्रिक यूज कर लेते हैं। सो दिस इज एक्स स्क्वायर, अब इसको यू कैन राइट इट, सो दिस इज नथिंग बट मॉड एक्स, राइट? सो क्या डेल्टा लेना चाहिए हमें? which is equal to mod x minus 0. So let
एप्सिलॉन।
delta, okay sorry, इस epsilon हमने पहले लिया नहीं था, then so इसको स्टार बना देते हैं, call it a star. Now for any epsilon greater than 0, if we take delta equal to epsilon, then from it star, it is easy to see that fx minus f0 upon x minus 0 is less than epsilon whenever 0 is less than x minus 0 less than delta, right? So fx minus f0 upon x minus 0 is less than epsilon whenever x minus 0 is less than delta. So by definition of differentiability, f is differentiable at 0 and f dash 0 is equal to 0. ठीक है, is it fine?
यस सर।
So this is how you can prove it. ठीक है, ये अगर इस तरह के डिरिचलेट टाइप के आते हैं तो you can always prove it like this. Okay, we are also above time also, I'm sorry. So let us end this class. Okay, bye everyone, have a good day.
थैंक यू सर।
Okay, bye bye.
Thank you for watching this video. To stay updated, please subscribe to our YouTube channel, Cosmos Learning. Happy learning through Cosmos Learning. To watch more, click on any of these cards. Thank you once again.